Hello, everybody. Welcome to the IMS 2021 session. This is Corvo, and I'm Suma Kapilavai. I'm the product line manager of 5G product line targeting base station. Today, we're going to talk about how Corvo has been leading the solutions targeting 5G infrastructure needs, and what are the different challenges that we are able to address and how. So let's get started. Uh, to begin with, let me go over the 5G market here. This slide shows some pretty staggering numbers. This graph here is from the Ericsson Mobility Report. We see an exponential growth in the global mobile traffic. It's expected that more than 1 billion people already have true 5G coverage around the world right now. And by these estimates on these curves, 60% of the world population will have 5G coverage by 2026. And in North America alone, 80% will have 5G coverage by then as well. There will be probably close to 30 billion IoT connections by 2025, and each smartphone user will be consuming more than 25 gigabits per month just through the network, not considering Wi-Fi at all. And the 5G value chain itself could be generating $3.5 trillion in revenue, and in turn supporting millions, tens of millions of jobs globally. And not only that, 5G will add an estimated $4.8 trillion to the global GDP just by 2023. That's 2 years away. So we cannot be more excited than what the possibilities are. The second graph here shown here is Corvo and industry market estimates on the share of each sub-market within the 5G space, primarily targeting the RF section. That's where Corvo plays. And you can see that the sub 6 gigahertz pretty much claims majority of the current deployments worldwide, and the content of GAN solutions for sure and high performance RF small signal contribute majority of the growth. This is the green and the orange section of the bar graph here. So this is where Corvo shines, and it's very well positioned to win this market and lead and be the lead provider for best-in-class products. Let's also touch upon the ecosystem, or what is the promise of 5G and what does it include under its umbrella. So there are three basic drivers, or I'm sure many of you are quite familiar with this already, but I'll go over it briefly. Three main drivers or for the use cases of 5G: enhanced mobile broadband, EMBB. This is by far the largest immediate market that 5G will address, as it's consumer driven and also the quickest path to realizing a return on mobile network operators' investment. The network is expected to handle 10,000x more traffic with peak data rates of more than 10 gigabits per second and at an average of 100 megabits per second. I can't wait to have that level of speed with any of my gadgets. It's said that the rate at which the smartphone sales have risen, a person may not have a roof over their head, but surely will have a smart device, a phone or a tablet with this kind of connectivity. Given just this fact, it shouldn't be surprising that we will see more than 1 million devices simultaneously active in any given square kilometer. Probably the number of devices is going to be more than the population around the world for sure. The next use case is the URLC, which is short for ultra reliable low latency, which is for mission critical services here. This use case creates a lot of verticals. The primary need here is very fast response, which is low latency and high quality of service, as in high reliability, that is zero interruption. Industrial manufacturing sectors with critical machine communication needs will drive the adoption of 5G in this region or in this use case. Medical applications are also fall under this category and represent some very, very innovative and promising growth sectors. The third driver is massive machine type communication. IoT is the primary use case that falls in this bucket. NB-IoT, CV2X, cellular vehicle to everything, smart grid are some of the interesting use cases that fall under this umbrella. So overall, it's not just cellular connectivity as traditional 4G. 5G has so many possibilities and already in the works, uh, maximizing efficiency in various vertical markets. So pretty exciting. And you can see how all of this also increases the SAM of the 5G space that we could address with pretty innovative solutions. So here I'm showing you the global spectrum allocations for the different regions. Uh, since we are addressing primarily sub 6 gigahertz 5G market, and that is the current growth market, and that will continue to be the majority of the deployments around the world for 5G coverage, I'm only showing the sub 6 gigahertz allocations here. You can see down below, these are existing 4G, and here are the latest 5G, true 5G band allocations around the world. The frequency around the 3.5 gigahertz is most common among every single geographical region. So this is by far the most popular and most widely available as well in every region of the world. So for North America, it's a C-band. The auction just ended, uh, generating $81 billion in bids, and Verizon has grabbed the majority of the licensing, and Verizon, AT&T, and T-Mobile are all partnered with the major OEMs such as Samsung, Ericsson, and Nokia with deals to develop radios targeting the entire C-band spectrum, which is 3.7 to 3.98, which is for North America. So there's already deployments that are starting, and Corvo is already engaged with all of these customers. Other bands, 2.5 gigahertz is also a popular band around the world, and the 5 gigahertz or the 4.5 to 5 gigahertz is primarily focused around Japan, but we've heard it is also a band in China as well, so there could be future applications starting up once the low bands have all been addressed. Moving on, here we see how these new spectrum allocations we looked at in the previous slide translate to the shift in technology projected in the various regions of the world. This is the mobile subscriptions by region. Obviously, to have a network to really benefit from the advantage of the network, you need to have the right user equipment. So definitely, we already know that Apple, Samsung have true 5G phones out there. They've already released in the market, and almost all of the phone manufacturers are coming out with 5G capable devices. So it's you can see the trend where the orange section progressively increases in share. So definitely biggest shift we can see is North America. That's a huge shift. This is from 2020 to 2026. 80% of the population will be connected to a true 5G network. And China definitely has been the lead, which they already have an existing 5G network, a massive 5G network. The next, of course, Europe is well positioned, and other Asian countries. India has a very big market in terms of given the population. The number of base stations to cover the population, the number of UEs is fairly high. So a good promising market is the India market. So how is Corvo positioned to address all of this technology leap that we just talked about? Here I'm showing you what Corvo is engaged with, the technology that enables 5G. Corvo is primarily known for state-of-the-art gas solutions and GAN technology, but Corvo is also as much involved and driven to use other technologies. Here I show SOI and SIGI. We have current solutions that extensively use SOI technology and SIGI as well to address various markets. It's both handset side and on the infrastructure side, we do incorporate every possible technology that best fits to meet the solution needs. And filters, of course, we have a very good BAW and SAW technology in our portfolio, and we've been the leaders in providing filter technologies, both as standalone and integrated into so many of our devices. Switch technologies, of course, we have proven both CMOS, SOI, gas switches, and GaN as well going forward for high power capability. So very well positioned to address every single RF block with every single technology that best fits that need of the market. So uh, really excited to be able to leverage all of these expertise and coming up with solutions. So let's jump into the 5G radio. Uh, as we know, 5G radio is as an active antenna array. So it is a panel of either 32 or 64 elements in a single radio unit. Here I'm showing you two sections of it. So two transmit, two receive, and this represents the antenna array of a 5G radio. So from the transceiver to the antenna, pretty much Corvo has solutions to address every single block, except maybe the isolator. But otherwise, we have excellent PA solutions, receive integrated solutions, drivers, pre-drivers. And we are engaged with all of the prime customers to provide solutions for each of these blocks shown here. Uh, if we focus on the GaN PA, for 5G, efficiency is primary because, as like I said, there are 32 elements or 64 elements in any given radio. If you compare that to a 4G system, which is 2T2R or just maybe a 4G4R, this is this is quite a big leap. It is 8x the number of channels in a given radio, or 16x. So therefore, high you can see how the power dissipation can multiply in the radio. So definitely efficiency becomes a very key parameter they need to focus on. So therefore, the PA has to be a high efficiency PA, and we can realize that by a Doherty design. But that makes it extremely nonlinear. So therefore, DPD is extensively used in 5G systems, where its linearization techniques are employed to linearize the transmit chain. So, and not just that, the PA needs to be designed to be able to handle up to 200 megahertz of instantaneous bandwidth. That is true NR, which is 5G NR signals, which can be as wide as 200 megahertz. With a single carrier. So definitely that is something a key we've excelled in. It's a key specification for 5G, to be able to design a part that is high efficiency but also linearizable with very wide signal bandwidths. And we've so far been quite successful in putting out products that are addressing those needs. You can see the sum of just the GaN, just the PA content for targeting 5G. That's like close to a $3 billion market here. So it's amazing the amount of, given the content that goes into every single radio and the density and the proliferation of 5G. These numbers are staggering, but it totally makes sense with the scale at which the market is moving. And Corvo is definitely positioned to grab that share. Next here on the chain where Corvo has solutions is the pre-driver here. This would be a very high gain, fully integrated solution with more than 30 dB of gain. We have both linear drivers and slightly non-linear, which requires linearization depending on the need of the end customer and the application. They're all internally matched. They're very wide band designed, so they cover the entire 5G space, frequency space, that is 2 gigahertz all the way to 5 gigahertz with a single product with no matching needed. So we have a whole portfolio of pre-driver products to address this slot here, and we've been extremely successful with those solutions. The next is the receive. So Corvo has already established itself as the lead provider of LNA technology, LNA solutions. We have the best-in-class noise figure performance, linearity performance, and at the same time, we are proven to be able to address the scale. We can scale towards any market needs. At 4G, we've been successful, and 5G, we've already proven to be able to meet the demands of 5G market. In fact, there have been instances where we had to make up for a shortage and double up our supply chain, and we were quite capable of doing that and address customer needs. So on the receive side, we have a whole generation of products. Since 2018, we've had multiple products and improvements over them as well. It's a dual channel, highly integrated two-stage LNA with a high power switch. Again, these are all internally matched, very wide band. That is, a single product can cover the entire frequency range of 5G market. And we currently have solutions in the market designed into all the main uh, radio manufacturers, and we use the best technology to realize each of these sections. The LNAs, of course, we have the best gas technologies, and the switches, high power switches, these are SOI switches. We use SOI technology, the best of the SOI technology out there, to realize power handlings of more than 20 watts. That is 20 watts average power. So the peaks can be anywhere close to 100 watts or more. So we have successfully designed these into major radio customers. And we also have differential driver solutions already released and more products being worked on. These are differential input or differential output, depending on used in the TX or the RX side. So these are very nifty products, gain blocks, again, wideband matched. No external matching needed. These can directly interface with the transceiver without requiring any external discrete balun to be placed. So they definitely help with minimizing board space and simplifying the design or the radio lineup. So these are all the solutions we currently have and are working on further improvements, either in performance or integration or moving to newer technologies. Those are all in Corvo's roadmap and very well positioned. Just a brief, I won't spend too much time on the product highlights. These are available on the Corvo website. This is the pre-driver. Currently we have like I said, it's wideband matched, very high gain, more than 35 dB of gain, and it's linearizable with very wide signal bandwidths, and in a compact 3x3 package. And on the receive side, like I said, the dual channel switch LNA. This is a 6x6 packet size, capable of handling 10 watts of average power by the switch, with again very wideband capable, and with best noise figure, like you can see, better than 1 dB of noise figure, 1 and 1.2 dB at the high end. So this is very well, and we have more products to be released into the market with even improved performance. Highlight here on the standalone LNAs. These are 4 LNAs that we recently released. These are 2x2 package QFN LNAs. These are from our latest Gen 3 PHEMT process, and very excited about these. They have already had a lot of traction in the market as well. So very well positioned, especially the QPL 9547, where we are able to have at 2 gigahertz, 0.3 dB of noise figure at 2 gigahertz. Very excited about these products. So please have a look. Moving on, briefly, I'll touch upon small cells and how they fit into the 5G ecosystem, what is Corvo providing in this space. Small cells, what are small cells? They are essentially base stations, but they cater to a very small segment of the macro cell site. So you can see how the coverage area reduces for a small cell compared to a macro cell. That's pretty much, and this table gives you the coverage radius of the various small cell subdivisions of small cell, like a femtocell, picocell, micro, macro. The femto, pico fall under the small cell market. So small cells help with coverage enhancement in very dense urban areas such as downtowns or stadiums or train stations and malls where signal penetration is hindered by multiple obstacles. Yeah, in addition, they also help with capacity boost at venues such as stadiums, right, where the UE density is quite high. So they provide the capacity boost at the such venues. So small cells were a huge hit, or they actually got a lot of traction during the 4G revolution, where once 4G macro cells were deployed, there was a big wave of small cell deployment as part of densification to enhance the 4G network. And now again, it's the same thing for 5G. Also, the 5G density of radios is fairly high because of the directive nature of the beam, but still small cells are still needed in highly urban areas, like I said. So small cells are still very well positioned to address densification needs for 5G as well. So, some of the scenarios where you would deploy your small cell, like I said, there are four categories for a small cell: carrier, outdoor, indoor, enterprise, residential, providing different settings where they would be used. Carrier outdoor, of course, it's dense urban outdoor areas at street level, like downtown areas. Carrier indoor is in malls, stadiums, train stations where signal penetration is a problem. Enterprise small cell is for manufacturing sites where you it's not coverage, it's connectivity, it's quality of service, and uninterrupted service is what is important for these applications. So small cells are preferred over, say, Wi-Fi coverage, because small cells employ the licensed band where you can have some level of guarantee of uninterrupted connectivity. Residential FEM2 is also a use case. It's fairly small compared to others, but that is still a market that could be addressed with 5G, that or could grow with 5G. This is a comprehensive table of Corvo's small cell portfolio. You can see we have solutions to address both FDD and TDD requirement. And we've had small cell solutions to address the 4G, FDDs, and TDD needs from quite many years. We've had solutions for the past, I don't know, 8 years. So we have filter solutions, like you can see, very large portfolio of filter solutions to address all frequency ranges from 700 all the way to 5 gigahertz. And we have LNAs, of course, very wide portfolio of LNAs to address all the way from 400 megahertz to 6 gigahertz or beyond. And bypass LNAs are a very popular LNA architectures that are used in small cells to simplify the front end, given the small size of the small cell. There are in the past linear PAs were the requirement for small cells. So we've had a whole bunch of products released in the market. They've been in the market for about 6 years now, and they are very, very successful. They've been successful to address the 4G needs, and now with 5G, like I said, the even the small cells have gone to 44R, where a higher channels in a single radio, so therefore efficiency is become a requirement with the use of DPD. So therefore high efficiency PAs are the requirement for small cell as well. So that means Doherty architectures are the path to realizing those, and at the same time being able to handle very wideband signals, like I said, 200 megahertz of instantaneous bandwidth. So we've already had 9908, 9903, 9901 released in the market already, and we are about to release the higher bands here 40 or 7, 42, and especially 42, which addresses the 3.5 gig. The 3.4 to 3.8 coverage of 9942 is very lucrative to address. Like I said, the 3.5 gig is a band that is ubiquitous around the world, so it can find itself applicable to a lot of markets around the world. So pretty excited about the entire small cell portfolio. Very well positioned there as well. All right, so this was a very brief overview of what some of the 5G radio challenges are and how Corvo is positioned to address them with state-of-the-art products and small cells as well. Please do check out our website for more information. And this is a really interesting section of our website, Corvo Design Hub, where you can find a lot of information like videos, blog posts, brochures, articles, white papers on any market or technology that Corvo addresses. We also have block diagrams that helps you better understand different applications and how each application requires a certain need to better appreciate the products that Corvo puts out. And our blog, of course, very interesting articles that we are constantly churning out. Please do check that out. And we obviously have very, very nifty design tools that I use on a daily basis. And any engineer, any person who deals with RF will benefit from using these. So please check them out. Thank you very much and hope to connect with all of you in the future.